My name is Muhammad Semizul bin Muhammad Ikhwan. My metric card number is CF230081. So I will start with the introduction. In this project, we are using the differentiation and integration as a method to solve the problem 1 and 2 in our project according to the task given. We use the derivative to determine the maximum and minimum values of particular function. Derivatives are crucial in describing natural process because they involve derivative. Many branches of mathematics use derivative and their generalization, including complex analysis, function analysis, differential geometry, measure theory, and abstract algebra. Integral can be used for computing the area of two-dimensional region that has curved boundary, as well as computing the volume of a three-dimensional object that has a curved boundary. The area of two-dimensional region can be calculated using the aforementioned definite integral. Almost all quantitative disciplines can benefit from the differentiation.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ahmad and my metric number is CF230113. And from this, and I will talk about problem 1. And for our project, we will choose Terengganu and we choose 5 station. Station 1, Kampung Keruak. Station 2, Kampung La. Station 3, Jambatan Jetih. Station 4, Institut Pertanian Tok Do. Session 5, Sekolah Kebangsaan Kampung Jabi. Okay, next, let's start with the data collection process. Here we have the daily rainfall data for 5 stations: Kampung Keruak, Kampung La, Jambatan Jetih, Institut Pertanian Tok Dor, and Sekolah Kebangsaan Kampung Jabi. The data collect from the 27th of May to the 9th of June. As we can see, the rainfall measures are listed in the millimeter for each day. Okay, next we analyze this data visually. This graph represents the daily rainfall versus time for all 5 stations in the same charts. The x-axis show that the day of the data collect, while the axis y show the rainfall in millimeter. Okay, we will talk about the graph. Kampung Keruak, blue line, show a significant rainfall peak on the 13th of May with around 16.5 mm. And Kampung La, orange line, has the highest rainfall on the 29th of May with 49.5 mm, indicating a heavy downpour on that day. And for Jambatan Jetih, red line, also experienced a peak on 13th of May with 18 mm, showing a trend similar to Kampung Keruak. Institut Pertanian Tok Do, yellow line, show minor rainfall with small peak, indicating occasional light shower. And for the last, Sekolah Kebangsaan Kampung Jabi, purple line, see a noticeable rainfall on the 31 of May and 9 of June with value around 50.5 mm and 9 mm respectively. Thank you.
Okay, my name is Muhammad Sham. I will continue about problem 1, which is first is station Kampung Keruak. Okay, as you can see, the equation for rainfall at Kampung Keruak, second derivative, and day 2 to 4 positive slope, day 6 to 7 negative slope, day 7 to 12 a flat slope, and result in a gradient of 0. This is the rainfall graph for Kampung La and the equation for Kampung La. For this is the graph, rainfall graph for Jambatan Jetih and the equation for Jambatan Jetih. This is the rainfall graph and equation for Institut Pertanian Tok Do. This is the rainfall graph and equation for Sekolah Kebangsaan Kampung Jabi. Now I will explain about the interpretation of the slope of the rainfall versus time graph. Okay, first, what is positive slope? Positive slope is a slope indicate an increasing rainfall intensity over time. Second is zero slope. Zero slope means that there is no change in rainfall intensity over time. And third, negative slope. Negative slope suggests a decrease in rainfall intensity over time. And lastly is magnitude of slope. The magnitude of slope provides information about the intensity of the rainfall. Okay, and lastly, my part is identify the global and local extremum for the station that we choose, which is 5, Kampung Keruak, Kampung La, Jambatan Cerdeh, Institut Pertanian Tok Dor, and Sekolah Kebangsaan Kampung Jabi. Okay, I will explain first for Kampung Keruak. For global point is the third day recorded rainfall as high 31.5 mm. For local point map, the 8-day recorded rainfall 29.5 mm, and the local point minimum is first day recorded of the rainfall is 0 mm. For Kampung La, global point is third day recorded rainfall as high 49.5 mm. Local point maximum, the 7 record day recorded rainfall of 8 mm, and for local point minimum is first day, which is 0 mm. For Jambatan Cerdeh, global point is at 8 day, which is 37.5 mm. For local point max is at 7 day, which is 32 mm, and the local minimum is first day, which is 0. And for Institute Pertanian Tok Dor, for global point is at 7 day, which is 38.5 mm. For local point maximum is at 8 day, which is 38 mm, and minimum is at first day, which is 0 mm. And lastly is at Sekolah Kebangsaan Kampung Jabi. For global point maximum is at third day, which is 50.5 mm. For local point maximum is recorded at 8 day, which is 8.5. And lastly is the local point minimum is at first day, which is 0 mm. Done. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Faiz Hakimi bin Jaafar, metric number CF230132. I will start our problem 2 explanation. Fracture energy, which is also called toughness, is a feature of a material that shows how well it can absorb energy and can change shape before it breaks. It is an important property in materials science and engineering because it shows how hard a material is to break under different loads. When talking about fracture energy, people usually talk about it in terms of joules per cubic meter or another unit of energy. It is found by integrating the stress-strain curve, which show how the material reacts to a force, all the way up to the point where it breaks. The energy that the material takes in before its break is shown by the area under the stress-strain curve up to the point of breakage. Font et al. Did an experiment to see how eggshell powder affects the shear strength of adversely bound joints. They used the double cantilever beam method to see how much energy the material had to break. The result can be found in Appendix A.
Alright, for the first method, we are going to do a direct calculation to obtain the area on the graph using the trend line equation. And as you can see from our calculation, we have using the trend line equation that have been generated from Microsoft Excel, and we have put the limit to 0.422 and 0 for the bottom limit, and the answer that we have obtained is 0.01025 kilonewton millimeter square.
Okay, I start our presentation for second method. In second method, load and displacement are already given in Appendix A, and we need to find area under the graph. We get total area under the graph 0.02942585. Total area between 0.00 to 0.108, we get 0.02943 kilonewton millimeter square. Total area under the graph, we get 0.03961 kilonewton millimeter square. Different first and second method, we get 0.02936 kilonewton millimeter square.
Alright, so let's move on to the comparison between the two methods. As you can see from the previous slide, so the first method provides a direct calculation of the area using the trend line equation, and for the second method, we have calculated the area under the graph by summarizing areas of each portion of the data up to the maximum load using the trapezoidal rule. And we can see that there is some difference between the two methods final answer, which where the difference is about 0.02936 kilonewton millimeter square, and this difference can be attributed to the accuracy of the trend line equation that have been used in the first method and the decreasation of the data in the second method. So the choice of method may depend on the specific requirement of the project and the desired level of the accuracy of the data. As you can see, for the first method, we have provided a direct analytical approach, while the second method relies on a numerical calculation, where both methods have their strengths and weakness, and the best approach may depends on the specific needs of the project, which are for our own preference. We prefer the second method, which is the data is more accurate for us. Thank you.
Conclusion for two methods. Both methods have their strength and weakness. The first method provides a more direct and analytical approach, but it relies on the accuracy of the straight line equation. The second method, while more numerical in nature, may capture the continuous nature of the curve more accurately. The choice of method ultimately depends on the specific requirements of the project and the desired level of accuracy. If the straight line equation is a good fit for the data, the first method may be more appropriate. If the data is more complex or the straight line equation is not a perfect fit, the second method may provide a more accurate result. In either case, it is important to consider the limitation and assumption of each method and to choose the approach the best suit the needs of the project. By understanding strength and weakness, of each method, researchers can make informed decisions and produce reliable results. That's all for our group presentation. Thank you.